All right, this is 6.9, graphing rationals. Okay, so today we're going to look at when we're just given one fraction and we have to factor. So this is a little bit different than how it was last time with the transformation. So you're not going to see a d value and you're really not going to have a true c value. And so what we have to do is three simple steps when we're solving these or graphing them. One, we're going to factor. Two, we're going to cancel if we need to. And then in parentheses, I want you to write whole right here. We'll talk about that here in just a second, what a whole is. And then three, we're going to set equal to 0 and solve. Okay, so this is going to be how we find the vertical asymptote, so the VA. So the VA is everything in the denominator, okay? So number one, I'm going to go through these and I'm going to kind of factor all of these out. Okay, so for this one, this is a normal GCF, so I take a 2 out, and then I get x minus 2 as a factor. Here is the difference of squares, so I factor both of those. One factor is x minus 2, the other factor is x plus 2. Then I'll go ahead and factor number 3. I know this is going to give me x and x. Things that multiply to 1, 1 and 1, they both are positive because they'll sum to get 2. So I have x plus 1 times x plus 1. This one's numbered a little bit different again, but I'm going to do this number 1. This gives me, actually that can't be factored, so that just stays the same. This is the difference of squares. So I have x minus 3, x plus 3. And then this one factors to be x minus 1 times x plus 6, I believe. Okay, so we've done step 1 for all 6 of these problems. Okay, we factored. Then what I look for is to see if anything cancels. Nothing cancels here with the numerator that I can tell, and so we're just going to skip step 2 right now, and I'll talk more about wholes later in this in these notes. Okay, so when we factor, the thing we do next is set equal to 0 and solve. So we're going to set any factor in the denominator that has an x. So this factor has an x. So we're going to set all of them equal to 0, and then we're going to solve. So for this one, we have x minus 2 is equal to 0. So that factor has an x in it, set it equal to 0, and then we simply add 2 to both sides. So x is equal to 2. And so that's the VA for that problem, x equals 2. For this one, it has 2 factors, okay, both of which have an x. So we take both those factors, x minus 2, and set it equal to 0, and x plus 2 and set it equal to 0, and then we solve for x. So we simply move that over. X equals 2, x equals negative 2 for this one. So this one problem actually has 2 vertical asymptotes. Okay, so it has one that's positive 2 and one that is negative 2. And then for number 3, you guessed it, we're going to have 2, or it looks like we're going to have 2 again. So when I set that equal to 0 though and solve, you're going to see that it equals the same thing. Sorry, it should be negative 1. So if they ever equal the same thing, then you really just have one VA at that one intersection. X equals negative 1. And this one we set equal to 0. 3x plus 2 is equal to 0. We just set the entire denominator because we don't need a factor. And we start solving. 3x is equal to negative 2. And then x is equal to negative 2 divided by 3. So again, that's the VA. Here, again, set them equal to 0. X equals positive 3 here, and x equals -3 on that one. So again, 2 VAs for that one. And then you guessed it, like, do I really need to show this step right here? Some of you guys are getting it. So I have two factors, I'm gonna have 2 VAs, so this one's gonna be x equals +1, and this one's gonna be x equals -6. So both of those are also the VAs.